Hi everyone, and welcome to my presentation on the role of machine learning in the understanding and design of materials. This is based on a research article by Mosavi, Jablonka, and Smith. My goal today is to walk you through how machine learning is changing the way we discover and design new materials, especially for those like clean energy, better batteries, and smarter manufacturing. So what is machine learning? Machine learning, or ML, is basically a way for computers to learn patterns from large amounts of data. In material science, machine learning is helping us move away from slow trial and error experiments, and instead we can now predict how materials will behave before even making them. This speeds things up and helps researchers focus on better options. Next up, we have the materials design process. So designing materials usually starts with figuring out what we need them to do. For example, hold hydrogen or capturing CO2. Then we look through a huge number of known or predicted materials to find good matches. Machine learning helps by scanning big databases and finding patterns that point to promising materials. It also helps fill in the blanks when data is missing, saving time and effort. Predicting material properties. One of the biggest jobs for machine learning in this field is predicting properties like strength, flexibility, or how well a material can store gas. This used to take a ton of time and lab work. Now computers trained on previous results can make quick, accurate predictions. Machine learning can also read research papers automatically and pull useful info, kind of like having a research assistant that never sleeps. From properties to performance. Great lab results don't always mean real-world success. Machine learning helps connect the dots between lab tests and how materials actually perform in real systems. It can predict things like how long a battery will last or how much a new material might cost to make. That's super useful for engineers who need to know the full picture. Here we're going to explore the chemical space. There are literally more possible materials than atoms in our universe. Testing them all is impossible. Machine learning tools like genetic algorithms and neural networks help us explore this massive chemical space efficiently. These tools can narrow down the best options without wasting time on unlikely candidates. Some machine learning tools go even further. Generative models like VAEs and GANs can actually design brand new materials from scratch. These models learn the rules of chemistry, then create new structures that match whatever performance we're aiming for. It's like giving the computer a challenge and letting it come up with creative solutions. Here we're going to go over lab automation. Once we have a material idea, we need to make it. That's where lab automation comes in. Machine learning can guide robots that run hundreds of experiments, testing recipes and finding the best conditions. Some labs are fully automated now, which means materials can be discovered and made much faster than before. Here are some challenges. There are still some big hurdles. A lot of useful data, especially failed experiments, usually isn't shared. That makes it hard for machine learning to learn everything it needs. There's also a problem of being biased when researching or models that don't explain their reasoning well. To fix that, we need more open science, better tools, and collaboration across fields. To wrap things up, machine learning is quickly becoming one of the most powerful tools in material science. It helps us design smarter, faster, and more efficient solutions to some of the world's biggest problems. From clean energy to better electronics, the possibilities are endless, as long as we keep building the tools and sharing the knowledge to make it happen. Thank you for listening, and here's my references.